According to the 2006 National Electrical Code, specifically Article 408.30, a subpanel serving a dwelling unit or another structure located on the same property as the main service panel must be equipped with either a main circuit breaker or main disconnecting means. There is an exception to this rule. A subpanel that is located within sight of and readily accessible from the main service panel is permitted to have a main lug instead of a main breaker. The main purpose of a main circuit breaker is to provide overcurrent protection for the entire subpanel and all of its associated wiring. If a fault or overload occurs, the main circuit breaker will trip, effectively isolating the subpanel and protecting it from potential damage. Given that the subpanel installed in the guest house is serving a dwelling unit that is a separate structure, it is mandatory that it includes a main circuit breaker. The inspector is justified in their requirement that the main lug be replaced with a main circuit breaker or that a disconnect be added outside of the subpanel. The relevant section of the 2006 NEC is Article 408.30, which states that a subpanel that serves as a distribution point for a dwelling unit or other structure on the same premises as the main service panel shall have a main circuit breaker or main disconnecting means. Let's delve deeper into the NEC requirements for subpanels, focusing on the essential aspects of main breakers and main lugs. Understanding these distinctions is crucial for ensuring electrical safety and compliance with local codes. Firstly, we'll explore the fundamental differences between a main breaker and a main lug. A main breaker is a circuit breaker installed at the beginning of a subpanel that acts as the main switch and overcurrent protection device for the entire subpanel. It's designed to trip and disconnect power to the subpanel if the current exceeds its rated capacity, protecting the wiring and equipment connected to it from damage due to overloads or short circuits. On the other hand, a main lug is simply a connection point for the incoming power conductors to the subpanel. It does not provide any overcurrent protection. This means that if an overload or short circuit occurs, there's nothing in the subpanel itself to stop the flow of excessive current, potentially leading to overheating, damage to wiring, and even fire hazard. Secondly, we will cover the location requirements that play a significant role in determining whether a main breaker is required or if a main lug is acceptable. The exception mentioned earlier, which allows for a main lug instead of a main breaker, is contingent on the subpanel being within sight and readily accessible from the main service panel. This means that a person should be able to clearly see the subpanel from the main service panel and easily reach it without any obstructions. The reasoning behind this exception is that in such a scenario, the main breaker in the main service panel can serve as the overcurrent protection for the subpanel. If the subpanel is not within sight and readily accessible, a main breaker is mandatory to ensure that overcurrent protection is readily available at the subpanel itself. Thirdly, we will cover overcurrent protection. Overcurrent protection is a fundamental safety principle in electrical systems. It's designed to prevent damage to wiring and equipment caused by excessive current flow. Circuit breakers and fuses are the most common types of overcurrent protection devices. They are designed to interrupt the flow of current when it exceeds a predetermined level. In the case of a subpanel, the main breaker acts as the primary overcurrent protection device, safeguarding the entire subpanel and its connected circuits. Fourthly, we will look into the specific requirements outlined in NEC Article 408.30. This article provides detailed guidelines on the installation and protection of panel boards, including subpanels. It specifically addresses the requirement for a main circuit breaker or main disconnecting means in subpanels serving dwelling units or other structures on the same premises. Understanding this article is crucial for ensuring code compliance and avoiding potential safety hazards. Fifthly, we should address the implications of non-compliance. Failing to comply with NEC requirements can have serious consequences. Firstly, it can create safety hazards, increasing the risk of electrical fires, shocks, and other accidents. Secondly, it can result in failed inspections, delaying or preventing the occupancy of a building. Thirdly, it can expose individuals and organizations to legal liability in the event of an electrical incident. Sixthly, what is the purpose of a disconnecting means? In situations where a main breaker is not required, a disconnecting means, such as a switch or another circuit breaker, must be provided at the subpanel. This allows for the subpanel to be easily de-energized for maintenance or repair purposes. The disconnecting means must be readily accessible and clearly labeled to indicate its purpose. Seventhly, let's consider the role of electrical inspectors. Electrical inspectors play a vital role in ensuring that electrical installations meet code requirements and are safe for use. They review electrical plans, conduct on-site inspections, and issue permits. Their job is to identify potential hazards and ensure that electrical work is performed in accordance with the NEC and local codes. Eighthly, when should you consult a qualified electrician? If you are unsure about any aspect of subpanel installation or NEC requirements, it is always best to consult a qualified electrician. A licensed electrician has the knowledge, skills, and experience to ensure that electrical work is performed safely and correctly. They can also help you navigate the complexities of the NEC and local codes. Ninthly, let's consider grounding and bonding. Grounding and bonding are essential safety measures that help to protect against electrical shock hazards. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and de-energizing the circuit. Bonding ensures that all metal parts of an electrical system are electrically connected, preventing voltage differences that could create a shock hazard. Subpanels must be properly grounded and bonded in accordance with NEC requirements. Tenthly, labeling and documentation is essential for ensuring the safe and efficient operation of electrical systems. Subpanels should be clearly labeled to identify the circuits they serve. Circuit directories should be provided to indicate the location and purpose of each circuit breaker. Accurate documentation, including wiring diagrams and panel schedules, should be maintained for future reference. 11thly, let's consider the importance of ongoing maintenance. Electrical systems require regular maintenance to ensure their continued safe and reliable operation. Subpanels should be inspected periodically for signs of damage, corrosion, or loose connections. Circuit breakers should be tested to ensure that they are functioning properly. Any necessary repairs or replacement should be performed promptly by a qualified electrician. 12thly, let's talk about the selection of the appropriate size main breaker. The main breaker size must be appropriate for the ampacity of the subpanel and the loads it will serve. It should be sized to protect the subpanel's conductors from overcurrent. The NEC provides guidelines for calculating the appropriate size of the main breaker based on the expected load. 13thly, let's consider voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Conductors should be sized appropriately to minimize voltage drop, especially in long runs. 14thly, let's talk about surge protection. Surge protection devices can help to protect sensitive electronic equipment from damage caused by voltage surges. Surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices should be installed at the main service panel and its subpanels to provide comprehensive protection. 15thly, let's delve into arc fault circuit interrupters, or SIs. SIs are a type of circuit breaker that is designed to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. SIs are required in many circuits in dwelling units, including bedroom circuits. 16thly, let's talk about ground fault circuit interrupters, or GFCIs. GFCIs are another type of circuit breaker that is designed to protect against electrical shock hazards. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. 17thly, let's consider the use of conduit. Conduit is a protective tubing that is used to enclose electrical wiring. Conduit provides physical protection for the wiring and helps to prevent electrical hazards. The NEC specifies the types of conduit that are permitted for different applications. 18thly, what about wiring methods? The NEC specifies the types of wiring methods that are permitted for different applications. Common wiring methods include non-metallic sheathed cable, armored cable, and electrical metallic tubing. The choice of wiring method depends on factors such as the location, the type of building, and the environmental conditions. 19thly, let's talk about box fill calculations. Box fill calculations are used to determine the maximum number of conductors that can be safely installed in an electrical box. The NEC provides guidelines for calculating box fill based on the size of the box and the size of the conductors. 20thly, let's talk about dirting conductors. Dirting is the reduction in the ampacity of a conductor due to factors such as high ambient temperature or the presence of multiple conductors in a raceway. The NEC provides guidelines for dirting conductors based on these factors. 21st, let's consider working space. Adequate working space must be provided around electrical equipment to allow for safe access and maintenance. The NEC specifies the minimum dimensions for working space based on the voltage and ampacity of the equipment. 22nd, let's talk about equipment labeling. Electrical equipment must be properly labeled to identify its voltage, ampacity, and other important information. Labeling helps to ensure that equipment is used safely and correctly. 23rd, what about panel schedules? Panel schedules are diagrams that show the circuits served by each circuit breaker in a panel board. Panel schedules are essential for troubleshooting electrical problems and for ensuring that circuits are properly loaded. 24th, let's talk about load calculations. Load calculations are used to determine the total electrical load that a building or system will require. Load calculations are essential for sizing the service entrance, the panel boards, and the conductors. 25th, what about service entrance requirements? The service entrance is the point where electrical power enters a building. The NEC specifies the requirements for the service entrance, including the size of the service conductors, the type of overcurrent protection, and the grounding requirements. 26th, let's consider emergency power systems. Emergency power systems provide backup power in the event of a power outage. Emergency power systems are required in many buildings, such as hospitals, nursing homes, and fire stations. 27th, let's talk about renewable energy systems. Renewable energy systems, such as solar photovoltaic systems and wind turbines, are becoming increasingly popular. The NEC provides specific requirements for the installation of renewable energy systems. 28th, what about swimming pool wiring? Swimming pools pose unique electrical hazards. The NEC provides specific requirements for the wiring of swimming pools, including the use of ground fault circuit interrupters and the bonding of metal parts. 29th, what about agricultural buildings? Agricultural buildings, such as barns and stables, also pose unique electrical hazards. The NEC provides specific requirements for the wiring of agricultural buildings, including protection against moisture, corrosion, and physical damage. 30th, let's talk about hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC provides specific requirements for the wiring of hazardous locations, including the use of explosion-proof equipment. These points should provide a more complete understanding of the NEC requirements for subpanels and electrical installations in general. It is always recommended to consult the latest edition of the NEC and to seek the advice of a qualified electrician for any electrical work.